Good afternoon, everyone. Am I audible?
Yes, sir.
Is the screen visible?
Yes, sir.
In the last lecture, we seen that one example. Okay. Today we will see more examples. Okay. How to solve the cost linear, semi-linear, non-linear partial differential equation. Now the question: find the integral surface of the following partial differential equation passing through the given curve. Okay. Question is find the integral surface, okay, of the following partial differential equation. Following partial differential equations passing through the given curve. Okay. First one, p square x, p square into x plus q into y minus z is equal to 0, and the curve is given by t is equal to 3, y is equal to 1, and x plus z is equal to 0. Okay, so this is the curve. Now let's look at the solution. Let f of x, y, z, p, and q is equal to p square into x plus q into y minus z is equal to 0. Give it as equation number 1. Be a non-linear partial differential equation. Okay, so this is the non-linear partial differential equation. Now to find its complete integral. Its complete integral by using Sharp's method. Sharp's method. Okay. What is the auxiliary equation of 1 given by? Yes, the auxiliary equation. Auxiliary equation of equations of 1 is given by what is the auxiliary equation? Dx upon Fp. Okay. Dy upon Fq is equal to dz upon P into Fp plus Q into Fq is equal to minus dP upon Fx plus P Fz is equal to minus dQ divided by Fy plus Qfz. Okay, so this is the auxiliary equation of equation 1. Now, write down dx upon what is effect Fp?
2px.
2px. Okay, first write down this equation. F is p square x plus qy minus z is equal to 0. Okay, and tell me now Fq. Dy upon what is Fq?
Y. dy
Y.
upon y.
So dz upon Pfp, that is
2p
2p
square
square x
plus q
plus
square.
qy. Okay, qy. Q into Fq now. So Fq is y
Ha, sir, yes, sir.
equal minus dp is equal to what is fx? P square.
2px.
Okay, minus p, which there is 1 now. minus 1. So minus 1 into p is minus 2. Okay, which is equal to minus dq upon q minus q. What is fy? Fq is fy is q plus qfz. Q into fz is minus 1. So q minus q is 0. Okay, now consider each ratio, this ratio. Okay, consider each ratio. Okay, that is dq upon 0. So that implies dq is equal to 0. So on integrating, we get it implies q is equal to a, which is the value of q. Okay, now put this value is equation 1, so we get the value of p in terms of x, y, z and a. Okay, put q is equal to a in equation number 1. So we get put q is equal to 1 in equation 1. So we get what is the equation 1? P square x plus qy, that is ay minus z is equal to 0. Okay, so that implies p square is equal to z minus ay upon x. Okay, so that implies p is equal to z minus ay upon x bracket as 1 by 2. Okay, so now here we find value of p and q. Okay, now putting the value of p and q in, dz is equal to p dx plus q dy. Putting values of p and q in equation, dz is equal to p dx plus q dy. What it implies? dz is equal to p is z minus ay upon x bracket as to 1 by 2 into dx plus what is q? A dy. Okay, now tell me how to calculate the integration of this one. Right, all again. इतना छोटा है ना z minus ay, then say dz and ay. Right, all again. That implies dz minus a dy. Okay, divided by z minus ay in the square root. Okay, which is equal to, okay, dx upon root x. Carried out. But so on integrating, we get क्या है इंटीग्रेशन कौन सा डेरिवेटिव
So 2 root x, 2 root z minus ay.
तो 2 to cancel होगा z minus ay.
Yes, sir.
Okay, so this is the derivative of square root of z minus ay, which is equal to say root x plus, now taking the integration constant, root b. Okay, for our convenience, take the integration constant root b. So here that implies taking on both sides, we get z minus ay is equal to x plus b plus 2 root x. Okay, a square plus b square plus 2ab. So that implies z minus ay minus x minus b is equal to 2 root xb. Okay, now squaring on both sides, we get, taking minus and common here, ay minus z plus x plus b. Okay, let us square number 4xb. Okay, do it as equation number 2. So which is the complete integral of given partial differential equation. Why? Because here the two constants are present, a and b, which is require the complete integral. Okay. Now, given that the complete integral passes through the given curve, which curve sees y is equal to 1 and x plus z is equal to 0. Okay. आता y is equal to 1 आणि x plus z is equal to 0. 3D मध्ये तुम्हाला इमॅजिन करता येईल हा एक्स असा जर तुमचा 3D प्लेन असेल कसा असेल तो कर्व हा एक्स हा वाय आणि हा झेड आहे. ओके वाय इज इक्वल टू 1 म्हणजे काय समजायचे 1 आहे म्हणजे हा तुमचा असा प्लेन आहे. ओके ओके या प्लेन मध्ये तुमचा कर्व आहे कोणता एक्स प्लस झेड इज इक्वल टू 0. एक्स प्लस झेड इज इक्वल टू 0 काय लाईन येईल ना टू मध्ये या प्लेन मध्ये लाईन येईल. ओके कसा असेल तो एक्स प्लस झेड खाली जाईल या प्लेन मध्ये तुमचा काय असेल तो कर्व. ओके एक्स प्लस झेड इज इक्वल टू 0 म्हणजे काय असेल एक्स इज इक्वल टू मायनस झेड. ओके जर एक्स मी 1 घेतला तर झेड किती येईल -1 म्हणजे हा इथे असेल एक्स -1 म्हणजे हा इथं कुठेतरी असेल. ओके एक्स 0 घेतला तर किती येईल वाय पॉईंट 0 म्हणजे हा असा कसा तरी लाईन गेलेला असेल या प्लेन मधून. ओके तो इमॅजिन करता यायला पाहिजे. ओके
Yes, sir.
so given that the complete integral passes through the curve C, that is y is equal to 1 and x plus z is equal to 0. तर हा कर्व तुमच्या इक्वेशन मध्ये कंप्लीट इंटिग्रल मध्ये पास होत असेल so it must be satisfies this equation. Okay, now putting y is equal to 1. Okay, now write down this equation in parametric form. First, y is equal to 1, x is equal to t, z is equal to minus t. Okay, now put x, y, z in equation number 2. Therefore, equation 2 becomes a plus a into 1. So this is a plus what is z minus t. So here minus 1 is plus t. Okay, what is x plus t? What is b as this? Okay, bracket square is equal to 4 b. So that implies a plus b plus 2t. Bracket square is equal to 4bt. Okay, now differentiate. Now differentiate with respect to t. We get okay. We want the relation between a and b. Okay, so eliminate this equation. In this equation, t. So here we get 4 into a plus b plus 2b is equal to 4b. Okay, so here plus 4 and this will get cancelled. So that implies a plus b plus 2b is equal
सर
to
टू
b.
आहे ना लेफ्ट साइडला एलएचएस ला.
कुठे
सर एलएचएस ला डिफरन्शिएट केल्यानंतर 2 येईल ना खाली सर.
हा ह्याचा कोएफिशियंट आहे.
ओके ओके सर.
2 into 2 4 ना. Okay, so this b range. This b and this b get cancelled. Okay, so that implies a is equal to minus 2t. Okay, now putting a is equal to minus 2, this equation, the equation with a is equal to minus 2t. Okay, we get put a is equal to minus 2 t in a plus b plus 2t bracket square is equal to 4bt. Okay, so we get implies minus 2t plus 2 cancel, so we will get b square is equal to 4 into b into t, so that implies b is equal to 4. Okay, any doubt up here? Any doubt, right?
No, sir.
Okay, hence we get the relation between a and b now. So that implies p is equal to b upon 4. Now put p is equal to b upon 4 in this equation. That implies a is equal to minus 2 into, that is t, b upon 4. 2 on the 4, it is 4. Okay, so that implies 2a plus b is equal to 0. Okay, that is b is equal to minus 2a. So we get the relation between a and b. Now on putting b is equal to 2a in complete integral, this way. So we get the one parameter family of curve. Okay, one parameter family, curve family. Okay, so on putting b is equal to minus 2a in equation second, we get one parameter curve family of the complete integral of partial differential equation 1 in the form. Okay, look at it. Ay minus z plus x minus 2a bracket square is equal to, okay, this one is 4 into minus 2a into x. Okay, so here we get one parameter family of curve. So that implies ay minus z plus x minus 2a bracket square is equal to minus 8ax. Give it as an equation number third. Okay, so now it is the one parameter family of curve. Now we have to find the envelope. Okay, so to find the envelope, so differentiate this equation with respect to a and eliminate a from the two equation. Okay, so we get the envelope. Now differentiate above equation 3 with respect to a. So we get 2 into ay minus z plus x minus 2a into याचा कोएफिशिएंट काय याचा y आणि याचा कोएफिशिएंट -2. Okay, is equal to, now differentiating we get -8x. Okay, 2 on the 2, 2 4 the 8. Okay, so that implies ay minus z plus x minus 2a into y minus 2 is equal to -4x. Okay, any doubt up here? Kind of set case?
No, sir.
Okay, wait a minute. Now look at here. आता त्याला रिअरेंज करा आपण. ओके, हा मायनस आहे, इथं बाहेर द्या, -4x -4x into 2a करूया. ओके, मायनस 4x व्हॅल्यू काय येईल मग इकडे ह्या 2a ला इकडे हे करा, divided by 2a. Okay, now look at this equation. Minus 4x on the right hand side, and here also minus 4x. So comparing these two equations, that implies that implies ay minus z plus x minus 2a bracket square divided by 2a, which is equal to ay minus z plus x minus 2a into y minus 2. Okay, so this one bracket get cancelled. So that implies ay minus z
सर कळालं नाही
x. कुठे
सर ते लास्ट सेकंड लास्ट स्टेप
हा आपल्याला काय करायचं डिफरन्शिएट विथ रिस्पेक्ट टू ए केल्यानंतर हा इक्वेशन आला तुमच्या. ओके,
येस सर
इथून काय कळालं, हा इथे 4x मायनस 4x व्हॅल्यू काय आली ही आली.
येस सर
ओके, आणि इथे काय होतं तुमचा हा 2a तुमचा इथे होता. ओके,
येस सर
एलिमिनेट करायचं म्हणजे हा मी काय केला 2a मी इकडे घेतला म्हणजे.
ओके सर
ओके, आता हा याचा राईट हँड साइड आणि याचा राईट हँड साइड कम्पेअर केला, मग काय येणार याचा लेफ्ट हँड साइड आणि याचा लेफ्ट साइड इक्वल येणार, तेच लिहिलं खाली.
येस सर
Okay, at the left hand side. Okay, now this bracket get cancelled, one bracket. So what remains? Ay minus z plus x minus 2a. Okay, it's equal to, now 2a कडे घ्या तुम्ही, 2a into y minus 2. Okay, now solve this equation and get the value of a. That implies ay minus z plus x minus 2a minus 2ay minus plus 4a is equal to 0. Okay, ay minus 2ay. So here you get minus ay. 2 minus 1, minus 2 plus 1 minus. Okay, minus z as it is plus x as it is minus 2 and minus plus 4. We get plus 2a is equal to 0. Okay, now take a common. First write 2a minus ay is equal to, take this one, z minus x. It implies a common 2 minus y equal to z minus x. So that implies a is equal to z minus x upon 2 minus y. Okay, so now this is the value of a. Okay, now put the value of a in this equation. Equation number third or fourth maybe. Let me wait a minute. Differentiate with respect to a particular. Wait a minute. Put the value of a here. Write down this is equation number 4. Okay, so we get the envelope. Now put the value of a, these values in equation 4. We get, okay, what is the equation number 4? Okay, y minus 2. Okay, y minus 2 into the right hand side minus 4x. Ay minus z plus x minus 2. Ay minus z plus x minus 2. Okay, now putting the value of a here, we get the envelope of that equation. Okay, solve करूया पुढे. Y minus 2 into bracket z minus x upon 2 minus y into y minus z plus x minus 2 z minus x upon 2 minus y is equal to minus 4x. ओके, हे सॉल्व करा. सॉल्व केल्यानंतर येईल ऑटोमॅटिक. ओके, आता मायनस साइन कॉमन करा. झेड एका बाजूला घ्या आणि वाय एका बाजूला, एक्स वाय एका टर्म एका साईडला. Okay, so we get the envelope of that integral surface. Okay, so this is the integral surface of the given partial differential equation which satisfies the initial condition, that is the curve which passes through that curve. Okay, any doubt? काही डाउट्स आहेत का? कोणती स्टेप समजली नाही?
No, sir.
Okay. Second example. Solve the Cauchy problem. Solve the Cauchy problem. Two into zx plus y into zy is equal to z. Okay, with initial condition is given by x naught is equal to s, y naught is equal to s square, and z naught is equal to s. So s is running in between 1 and 2. Okay. Between. Oscillating partial differential equation. Okay, now look at here. The given differential equation is the Cauchy linear partial differential equation. Okay, solution. The given partial differential equation is 2 into zx plus y into zy is equal to z. Question number 1. Okay, where p of xyz is equal to 2. 2 of x, y, z is equal to y. Okay, and r of x, y, z is equal to z. Okay, with initial condition. With initial condition, x naught is equal to s, y naught is equal to s square, and z naught is equal to s. Okay, look at here. The given partial differential equation is Cauchy linear. Okay, then first we have to check the condition of admissibility condition. Okay, dy naught upon ds into p minus dx naught upon ds upon into q. Okay, if it is not equal to 0, then there exists a unique solution of z of xy. It satisfies the partial differential equation and initial condition. Okay, method of solving the Cauchy linear differential equation. Okay, now consider first the condition of admissibility. Dy naught upon ds into p of x naught, y naught, z naught minus dx naught upon ds into q of x naught, y naught, and z naught, which is equal to, now differentiate y naught with respect to s. We get 2s. Okay, so this is 2s into p of x naught, y naught, z naught. What is the value of p? 2, constant. What is the value of 2 minus dx naught upon ds. X naught is what? Yes. So differentiate with respect to yes, here we get 1. Okay, and what is q? Y. So here we get 4 Just escape. What is the value of y naught? At point y naught. No, I want to just escape. Okay, it is equal to 3 s square, which is not equal to 0 in 1 to 2. Okay, या कंडिशन मध्ये हा तुमचा not equal to 0 होईल, कधीच 0 होणार नाही. Okay, so then by theorem there exists a then by theorem, previous theorem, there exists a unique solution. Unique solution set of xy satisfies the partial differential equation and key1 initial condition. Okay, the key1 condition. Okay, now we know that the family of characteristic curves which generate the surface are given by dx by dt is equal to p, dy by dt is equal to q, and dz by dt is equal to r. Okay, okay. Know that the family of characteristic curves which generate the surface are of the solution of equation dx by dt is equal to p, dy by dt is equal to q, and dz by dt is equal to r. Okay. Now what is dx by dt? Dx by dt is equal to p. What is the value of p? It's 2, na? Yes, 2. This is 2. dy by dt, 2. What is q? Is 1. Okay, and dz by dt is z. Okay, that implies dx is equal to 2 dt. That implies x is equal to 2t plus c1. Here, dy upon y is equal to dt. So here we get log y is equal to t plus ct. That is y is equal to e raised to t into sorry, e raised to into c2. Okay, or c2. And now here dz by x is equal to dt. So here we get log z is equal to t plus c3. So that implies z is equal to e raised to t into c3 or c2 dash. Okay, so here we get x, y, z in terms of t and c1. Okay, now using the initial condition, find the value of c1, c2, and c3. Now, hence, the family of characteristic curve to the initial data curve is equal to x is equal to 2t plus c1. Okay, y is equal to what? E raised to t into c2, and z is equal to e raised to t into c. Now the given conditions, from given condition, substitute the given condition here. So we get substitute given initial condition. Okay, so we get x naught of s is equal to putting t is equal to 0. T equal to 0 ठेवावा लागेल तुम्हाला initial condition. So here we get 2 into 0 plus t1. y is equal to e raised to 0 is 1 is equal to c2. Okay, and say y naught and z naught is equal to again e raised to 0 is 1 into c3. But what is x naught of s? Yes. Okay. What we will get x naught of s is equal to yes is equal to c1. Y naught of s is what? Hmm. S square. So here we get y naught of s is equal to s square is equal to c2. Okay, and z naught of s is yes, that is s is equal to c3. Okay, now putting the values of c1, c2, c3 in our equation x, y, z. That implies x is equal to 2t plus yes, y is equal to e raised to t into s square. Z is equal to e raised to t into yes. Okay. Now we get the values of x, y, z in terms of now t and yes. Okay. Now eliminate yes and t from above three equations and put into the z is equal to e raised to t into s. Okay. So we get the required solution. Now look at here. कसं सॉल्व करणार? How to eliminate s and t? Y is
So y
equal to
upon z घ्यायचं.
y is equal to e raised to t into s into s. But e raised to t into s is what? Z. So y is equal to z into yes. Is it correct? That implies yes is equal to y upon z. Okay. Now put the value of yes in x. So x is equal to 2t plus y upon z. That implies t is equal to x minus y upon z. Well, 1 by 2 into 1 by 2. So that is equal to x is minus y upon 2z. Okay, so that implies p is equal to x into z minus y upon 2z. That should be the value of s. This is the value of now t. Now putting s and t in z. Okay, now putting the values of s and t in last equation. So we get z is equal to what? E raised to t into the yes. Okay, so e z is equal to e raised to the bracket x z minus y upon 2z into yes. What is yes? Y upon z. Okay, that implies z squared is equal to y into e raised to x z minus y upon 2z. Okay, so this is the required integral surface satisfies the initial condition. Okay, so this is the required integral surface. Okay, any doubt? Okay, येईल सॉल्व करता.
हॅलो सर.
हा बोला.
सर तिथं आपण ते फॅमिली ऑफ कॅरेक्टरिस्टिक कर्व थ्रू इनिशियल डेटा कर्व तिथं सर व्हॅल्यूज पुटअप केले सर. ते कुठून पुटअप केले?
कुठे हे t इज इक्वल
हा
टू
येस
0.
सर. हा
हा ते इनिशियल कंडिशन आहे. इनिशियल कंडिशन मध्ये काय ठेवलं आपण, टी इज इक्वल टू 0 पुट केल्यानंतर आपल्याला इनिशियल
सर नेहमी टी इक्वल टू झिरोच पुटअप करायचं का?
हो हो, टी इज इक्वल टू 0 पुट करायचं.
ओके सर.
ओके, एकदा तुम्हाला एक्स वाय झेड मिळाले, मग युजिंग इनिशियल data curve. Okay, using initial condition, we get the values of x, y, z in terms of S t. Okay, now eliminate s and t and get the values of s and t in terms of x, y, z. Okay, and put in the z is equal to e raised to 20 x.
येस सर.
Okay, this process. आपण ऑर्डिनरी डिफरन्शियल इक्वेशन करताना आपण इनिशियल व्हॅल्यू प्रॉब्लेम, बाउंड्री व्हॅल्यू प्रॉब्लेम सॉल्व्ह करताना केले. तुम्हाला इनिशियल फाय ऑफ एक्स, फाय ऑफ 0 किंवा फाय डॅश ऑफ दिलेलं असतं. ओके, मग तिथं काय करतो तुम्ही, त्या व्हॅल्यूज तुम्ही पुटअप करून काय करता, C1 आणि C2 व्हॅल्यू काढता आणि शेवटी तेच व्हॅल्यू आपण आलेल्या आन्सर मध्ये पुट करतोय. ओके, फक्त इथे काय प्रॉब्लेम आहे, तुम्हाला इथे पार्शियल डिफरन्शियल इक्वेशन आहे म्हणजे असल्यामुळे सॉल्व्ह करताना अवघड वाटेल, ते बघताना अवघड वाटेल. ओके, पण इथेही तेच प्रोसिजर करत असतो. ओके, युजिंग इनिशियल कंडिशन टू फाइंड द व्हॅल्यूज ऑफ कॉन्स्टंट C1, C2, C3. ओके,
येस सर.
next example. Sorry. Find the solution of initial value problem. Find the solution of initial value problem for the Cauchy linear partial differential equation. Okay. For example, Zx minus Z into Zy plus Z is equal to 0. Okay. For all y and x is greater than 0. For initial data curve. For the initial data curve, remember x0 is equal to 0, y0 is equal to yes, and z0 is equal to minus 2s, where s is running from minus infinity to plus infinity. Okay. Now check the admissibility condition. Tell me what is the value of that one. Okay, solve for that. I will zx minus z into zy plus z is equal to 0. P of x y z by the scale of p of x y z is 1.
1.
P of x y z is
Minus
minus.
z.
And r of x y z is again
Minus z.
minus. Okay. Now dy naught by ds into p at point x naught, y naught, and z naught minus dx naught by ds at point q of x naught, y naught, and z naught. Find the value of this one. Why not yes? Just differentiate this surface now 1. Okay. E of x y z at point x naught, y naught, z naught point is a constant त्यामुळे 1 असेल. So 1 minus. Okay, x naught काय? X naught 0. So 1 minus 0. 0 into something or yeah, 0 into q is 0. So here we get 1. So which is not equal to 0 for s running from infinity to minus of 0. Okay. Hence, by the theorem, there exists a unique solution z of x y satisfied the partial differential equation with initial condition. Okay. Now, you know that the family of characteristic curves which generate the surface are given by are the solution of equation dx by dt is equal to p. मधल्या स्टेप दिस नाही बरं का, dy by dt is equal to q and dz by dt is equal to r. dx by dt. काय लिहिलं सर 1 dy by dt is equal to q is minus 1 dz by dt is equal to again minus 1. And first equation implies x is equal to t plus c1. Okay, आधी हे सॉल्व करा. dz by minus 1 plus x is equal to minus 2. Okay, I'll directly answer. Y is equal to e raised to minus 2 plus into c2 है. Okay, हा तुमचा y आला. Wait a minute. Sorry, हा z आला ना. Wait a minute. Okay. Z is equal to e raised to minus t into c2. Now put the value of z here. So dy by dt is equal to e raised to minus t into c2. So y is equal to minus e raised to minus t into c2 plus c2. Okay. Okay, any doubt?
No, sir.
सर प्लस है ना.
प्लस येईल का
यस सर.
कुठे झेड ची व्हॅल्यू ही आली ना
Sir,
e रेस टू
minus आहे.
मायनस टू मग हे झेड ची व्हॅल्यू आपण इथं पुट केली हा मायनस मायनस प्लस येईल करेक्ट ओके आता करेक्ट आहे
यस सर.
इथं मायनस येईल हा नाउ वी गेट द व्हॅल्यूज ऑफ एक्स वाय y and this is z. Okay, now substitute the initial condition. Okay, what is the initial condition? X naught of s is equal to 5 into x naught 0. Okay, y naught s and z naught minus 2. X naught of s is 0. Y naught of s is 10. Yes, and z naught of s is minus 2. Okay, now put t is equal to 0 and get the values of c1, c2. X naught is equal to 0 plus c1 is c1. What is x naught of s is? Yes. Okay, this is the value of c1 is equal to yes. What is y naught of s is equal to yes, which is equal to, now put here 0. E raised to 0 is 1. So we get c2 plus c3. Okay, and z naught of s is equal to minus 2s, which is equal to c. Okay, so that implies c1 is equal to yes, c2 is equal to minus 2s, and putting the value of c1 and c2 here. Okay, c2 is equal to minus c2 plus. So minus plus 3s. Okay, so that implies now put the values of x c1 c2 c3 in x y z. So x is equal to t plus yes. Okay, wait a minute. आता तो 0 है ना c1 0. Okay, x is equal to kind of t plus 0 is t. Y is equal to e raised to minus 2 into c2 ना, so minus e raised to minus 2 minus e raised to minus 2 into 2s plus c2, that is 3s. Okay, and z is equal to, what is the value of z? E raised to minus t into minus 2s. Okay, so here we get minus 2s into e raised to minus. Okay, so here we get the values of x, y, z in terms of s and t. Okay, now eliminate s and t and put the values of s and t in z. कसं करणार?
Sir, y
Take
is equal to
simple
z plus 3 SEL.
y is equal to
Z plus 3s. सर रिलेशन खालीच ते लास्ट स्टेप.
हा हा काढलं का रिलेशन तुम्ही
सर तीच
एस
म्हणालो.
व्हॅल्यू आणि टी व्हॅल्यू
ते एलिमिनेट
टी व्हॅल्यू हे
करायचं
आले
नंतर.
एस हा एस कसं ते सांग एस व्हॅल्यू पाहिजे ते सांगा मला
एस ची
एस
व्हॅल्यू
ची
वाय
व्हॅल्यू
मायनस झेड अपॉन 3 आली.
एस ची व्हॅल्यू का
हा
वाय अपॉन
येस सर.
वाय
झेड
मायनस झेड अपॉन 3.
वाय मायनस झेड अपॉन 3 इज इट करेक्ट करेक्ट आहे का
येस सर.
आलं का सगळ्यांचं हा ओके this is the value of s and this is the value of t now put s and t here then we get z is equal to okay minus 2 into yes is y minus z upon 3 okay into e raised to minus okay so this is the required integral surface okay which satisfies the initial condition okay any doubt okay now solve some example for homework उद्याचं एवढं सॉल्व करायचं संडेपासून थर्ड चॅप्टर चालू करायचं ओके ओके उद्या सॉल्व करूयात काही एक्झाम्पल ओके म्हणजे मंडेपासून आपल्याला थर्ड एक्झाम्पल सॉल्व करतोय थर्ड चॅप्टर सुरू करतोय ओके एनी डाऊट अप टू हिअर
नो सर.
ओके वेट अ मिनिट ओके थँक यू फॉर द अटेंडिंग ओके यू कॅन लिव्ह नाव
थँक्यू सर.